an AI-generated post for your viewing pleasure. Revolutionizing database query optimization with Aurora. A new AI-based approach. Imagine eliminating hours of wait time for complex database queries and slashing execution costs by orders of magnitude, all thanks to a groundbreaking new system called Aurora. This isn't just an incremental enhancement. We're talking about a fundamental shift in how databases can harness the power of AI and machine learning to redefine what's possible in query optimization. Say goodbye to outdated heuristics and hello to smart, data-driven query rewriting. Before we dive deeper, let's set the stage for what we're about to explore. We'll unpack how Aurora functions, the challenges it overcomes in query optimization, and why this research is generating excitement in the field of data management. Buckle up as we reveal the impressive capabilities of this innovative technology. Welcome to our channel where we unlock the latest breakthroughs in technology and data science. Today we're diving deep into the world of databases and query optimization, a realm filled with complex algorithms and sometimes maddening inefficiencies. If you're a database administrator, a developer, or just someone interested in the future of data management, this video is tailor-made for you. What if I told you that a new system, Aurora, is changing the game with its unique blend of deep reinforcement learning and equality saturation? By interleaving these advanced computational methods, researchers at the University of Cambridge have developed a system that not only accelerates the performance of SQL queries, but can also mean significant cost savings for businesses relying on data-heavy applications. It's a remarkable leap forward, and we're here to break it down for you step by step. Now, let's talk about the core concepts that underpin Aurora and set the context for our discussion. Query optimization involves enhancing the efficiency of database queries, which are essential for retrieving and processing data. Traditional approaches often utilize heuristics, rules of thumb based on empirical data, which can lead to slow execution times and inefficient use of resources. Meanwhile, equality saturation, a technique borrowed from compiler optimization, employs a more sophisticated approach by exploring many alternative representations of queries. To navigate these complexities, Aurora integrates deep reinforcement learning, which allows for dynamic decision-making based on a framework called Markov Decision Processes, MDPs. This means the system can learn and adaptively choose the best rewrite rules for optimizing query execution over time. However, while this approach is promising, it's crucial to consider the computational challenges posed by equality saturation itself, particularly in real-world scenarios where workloads can be diverse and unpredictable. With this foundational understanding, we are primed to delve into how the Aurora system is structured and why it represents a meaningful advance in database technology. Now that we have a clear understanding of what Aurora is and its significance, let's delve into the technical contributions that make this system exceptional. We'll break down how it functions, its design components, and what makes it superior to traditional query optimization methods. Aurora tackles one of the most challenging problems in database management: query rewriting. Traditional methods have long relied on heuristic algorithms that operate sequentially and often end up in local optima due to interdependencies among rewrite rules. This not only results in suboptimal query plans but can also lead to wasted computing resources. By interleaving equality saturation, a method from compiler literature, with graph reinforcement learning, this revolutionary system enables a non-destructive approach to query rewriting. The result? Significantly faster and cost-effective SQL query plans. How does it work, you ask? Aurora uses a combination of graph neural networks, GNNs, and recurrent neural networks, RNNs, to guide the application of rewrite rules. This dual architecture allows it to learn both the spatial relationships among query components and the sequential dynamics of query construction. Ultimately, Aurora can represent and manipulate multiple equivalent expressions efficiently, which is where the magic happens. However, it's important to note that while Aurora aims to mitigate the challenges of equality saturation, the authors themselves acknowledge that finding the optimal order to apply query rewrite rules is generally NP hard. This raises questions about the scalability of their approach in the face of dynamic, real-world queries. Additionally, the reliance on advanced neural network architectures introduces significant computational overhead, which could pose challenges in environments where resources are limited. With a solid understanding of how Aurora operates and why it's a significant advancement, let's explore the implications of its contributions and how it compares to existing systems in the field of database optimization. In comparison to existing solutions, Aurora stands out by effectively addressing the NP-hard nature of the query rewrite problem, an issue that has stymied researchers and developers for years. With empirical results showing Aurora yields orders of magnitude lower execution costs and quicker query plans than state-of-the-art equality saturation solvers and traditional optimizers, it's clear that this approach isn't just innovative, it's necessary. However, the evaluation of Aurora raises some critical considerations. The authors conducted their tests using a specific subset of queries from the TPCH benchmark, which is designed for online analytical processing. While this benchmark is recognized, the selective nature of the queries used may not fully represent the diverse range of real-world workloads that databases encounter. This could introduce bias, potentially skewing the results in favor of Aurora, as it may excel in the specific scenarios tested but struggle in broader applications. Moreover, the comparison of Aurora against existing methods lacks comprehensiveness. The paper primarily evaluates Aurora against other equality saturation solvers like eGraphs, Good, and Omelette, but it does not include comparisons with state-of-the-art commercial query optimizers. Such comparisons would provide a more realistic benchmark for assessing Aurora's performance in practical applications, as commercial optimizers are often optimized for a wide range of scenarios and workloads. Another critical point to consider is the fixed upper bound of 1,000 nodes for the eGraph size used in the experiments. While this constraint serves to manage memory usage during testing, it may not accurately reflect the variability of memory constraints in real-world environments. In practice, database systems often face fluctuating memory availability, and a fixed limit could affect the generalizability of the results. As such, while the experimental results indicate that Aurora can produce lower-cost query plans, the conditions under which these results were obtained may not fully capture the complexities and demands of actual database operations. In summary, Aurora represents a bold step forward for query optimization, merging deep learning with traditional database techniques to create an architecture capable of smarter, faster decision-making. The implications of this research don't just stop at databases. They extend into various fields like optimization problems in logistics, planning and autonomous systems, and even into software performance for developers. As this tech continues to evolve, we can only expect greater synergies between database management and AI-driven optimization strategies, paving the way for next-generation solutions that are more efficient, effective, and resilient. If you found this exploration of Aurora as exciting as we did, don't forget to give this video a thumbs up, subscribe for more cutting-edge tech content, and hit that notification bell so you never miss an update. Let's revolutionize the world of data together. Thanks for watching.